Hi everyone. Ever since Galileo first gazed up at the sky with the crude telescope he built himself, the mysterious night sky has become so much brighter, revealing far more wonder than its dark exterior ever suggested. More than 4 centuries have passed since then, and yet the universe keeps expanding before us, leaving astronomers stunned by its sheer scale. It seems like the cosmos is always larger than what we can see. Building bigger telescopes won't magically make the universe larger. They only help us see what's already there. You can't look back further than the universe itself is old, and that's a humbling thought. Because no matter how powerful our telescopes become, we hit a wall at the edge of the observable universe. That raises a profound question. What lies beyond, and can we ever see past it? Back in 1996, the Hubble Space Telescope captured its first famous deep-field image, an observation that revealed countless distant galaxies. Scientists pointed Hubble at a tiny patch of sky about 1/20,000th the size of the entire night sky, in the direction of the Big Dipper. When the image finally came in, they were astonished. It showed over 3,000 galaxies packed into that single tiny field of view. That image set the stage for a new era of cosmic discovery, allowing astronomers to explore galaxies with redshifts of 6 or more, light that had traveled for more than 1 billion years after the Big Bang. Over time, Hubble and other powerful telescopes have pushed this frontier even further. By 2010, astronomers were able to detect countless primordial galaxies at redshift 7 and higher, representing the first 500 million years after the Big Bang. With Hubble's super-sensitive eye, we have been looking deeper and deeper into the past, chasing objects with redshifts of 8, 9, and beyond, some of the earliest galaxies and quasars, as we trace the very formation of the universe itself. And now, with the launch of the James Webb Space Telescope, that horizon has expanded even more. The most distant galaxy Webb has found so far, Jade's GS-Z14o, lies some 34 to 35 billion light-years away. That light began its journey when the universe was less than 300 million years old. And beyond that, at the most extreme edge of observation, lies the cosmic microwave background. That faint, glowing afterimage of the Big Bang. At a distance of more than 46 billion light-years, it's the farthest thing we can detect with today's technology. And that sets our current limit. That's why astronomers say that what we can observe is vastly smaller than the full universe. So what lies beyond that background glow? And what exactly is the edge of the universe? When we talk about the universe we can see, the observable universe, we're really talking about a sphere of light that stretches as far as light has had time to travel at its finite speed. From where we stand, we see galaxies rushing away from us in every direction. That can give us the false impression that we must somehow be at the center. But if we picked up Earth and dropped it inside the distant galaxy Jade's GS-Z14o, the most distant galaxy we've seen so far, an observer there would also see the same thing. Galaxies racing away in every direction, with themselves at the center of their own observable universe. And that reveals a deeper truth. More likely than not, we live in an infinite universe, a cosmos so vast that we struggle to grasp the concept of infinity itself. We know the universe is expanding, which means it hasn't reached some fixed final size. And as it expands, it just keeps getting larger. But what does infinity mean in a universe that's still expanding? Some say if you could jump far enough away, you'd just see more of the same, endless galaxies fading into forever. And moving to some distant vantage point wouldn't help much, because every observable region is still finite. The real universe is far greater than the tiny observable bubble we live in. And here's the real puzzle. If the universe is infinite and expanding, then where is its edge? If you imagine the universe as a balloon inflating in 3-dimensional space, then, like the surface of a balloon, it might not have a true edge. And if that's the case, then even the concept of a boundary doesn't apply. But if the universe is three-dimensional, with up and down, front and back, left and right, and if it's still expanding, we're left wondering, does this mean there's some outside? Like the air surrounding a balloon? Is there a membrane, a border, or a true edge? That's what keeps cosmologists up at night. And this is where observations help us most. Since the 1980s, astronomers have built a network of observatories to study the cosmic microwave background, those ancient photons left over from the Big Bang. And so far, every precise measurement tells us the same story. Our universe appears perfectly flat and uniform. That means, on the largest scales we can measure, the cosmos has no detectable curvature. It looks the same in every direction. And even if you traveled forever, you'd never reach its edge. All you'd ever see is more galaxies stretching on into the unknown. That's the conclusion astronomers have reached. A flat universe matches every observation and every theory we have. And as much as we want to picture the cosmos like an expanding balloon with a clear center and an outer edge, that's not necessarily the case. The universe could truly be infinite, or at least so enormous that its edge is forever beyond our reach. And if that's true, then humanity is more insignificant and alone than we ever imagined. If space truly stretches on forever, then moving faster or going farther won't help us grasp its full scale. Stephen Hawking once remarked, "The universe itself may be hiding from us, making it difficult to ever truly understand. And after all, we're just tiny minds on a tiny world, part of a small civilization lost in the immensity of this cosmos. If even understanding our own planet can challenge us, what hope do we have of fully grasping the universe? And yet, what an amazing quest it is. When you really stop to think about it, it's remarkable that we've managed to see and understand so much already. Regardless of what the fate of the universe may be, whether it goes on forever or folds back on itself, one thing is clear. We need to keep trying to answer the biggest question of all. Why are we here? Does our existence matter? Or is it all just a grand cosmic accident, unfolding in a universe that feels anything but accidental? That's the wonder and the mystery we'll keep chasing under these endless stars.